Last time, we talked about building systems that work. Today, we're diving into why they keep working, even when things go wrong. What if the system you built today could fail tomorrow, but you wouldn't even know it? That opens up the real question for this episode. How do you build systems that stay up, even when the hardware, software, or people working on them fail? Here is the framing that makes the rest of the episode easier to hear. We are not trying to cover every branch of the chapter. Reliability isn't about avoiding failure, it's about designing systems that keep running when the world breaks around them. How do you build systems that stay up, even when the hardware, software, or people working on them fail? This episode isn't about how to debug a crash. It's about how to make sure the crash never happens in the first place. Picture this. You're at a data center, and the power goes out. You panic, but the UPS kicks in. No one even notices. But what if the UPS failed? You'd never know. Where it gets tricky is this. You can't test for every possible failure. You have to trust your systems to handle the ones that matter. The useful shift is this. Fault tolerance isn't about preventing all failures. It's about making sure the system keeps running when the unexpected happens. So the design move is this. Use redundancy, but don't rely on it. Test your fault tolerance with real-world scenarios. Take this moment. You deploy a new feature, and everything works. Then, a user reports a crash. You debug for hours. Finally, you realize it was a race condition that only happened when two processes collided. The catch is here. Software errors are hard to predict. You can't test for every possible interaction. What should really land is this. Reliability isn't about writing perfect code, it's about designing systems that can handle the messy, unpredictable interactions between components. So the practical move is, use automated testing, but don't stop there. Simulate edge cases and stress scenarios. Imagine the system on a rough day. A developer accidentally deletes a production database. You panic, but the rollback script kicks in. No one even notices. But what if the rollback failed? You'd never know. This is the part teams usually feel too late. Human errors are inevitable. You can't stop them, but you can make sure the system doesn't break because of them. The deeper lesson is this. Human errors are the hardest to handle. The best systems don't just recover from them, they prevent them from causing damage. The engineering response is, build systems that can detect and recover from human mistakes. Automate as much as possible. Now zoom out. Reliability, scalability, and maintainability aren't separate goals. They're all about building systems that survive, grow, and stay manageable over time. One more quick lens helps here. A developer accidentally deletes a production database. You panic, but the rollback script kicks in. No one even notices. But what if the rollback failed? You'd never know. Human errors are the hardest to handle. The best systems don't just recover from them, they prevent them from causing damage. If there is one thing to keep, make it this. The best systems aren't perfect. They're resilient, adaptable, and built with the assumption that something will go wrong every day. If you want to build systems that can handle the truth, you'll need to think about data like it's a language, and not just any language.